If you have a child with a rare disease, you have to go to a children's hospital like this one to get a diagnosis. But unfortunately, not everyone in the population has access to these. Worldwide, there are approximately 400 million individuals who are affected by a rare disease, which affects less than 5 out of every 10,000 individuals. It is crucial to obtain accurate diagnostic tests in order to allow for an early diagnosis and intervention. However, access to genetic testing is costly and is particularly challenging in non-urbanized areas. One of these rare diseases is Angelman Syndrome, a neurogenetic disorder associated with a characteristic facial appearance, developmental delay, excessive laughter, severely limited speech, seizures, and a small head. It is a genetic disorder caused by a problem in a gene on chromosome 15, with various mechanisms leading to the impairment of its function. The different subtypes include a deletion of the gene, a point mutation, silencing or abnormal methylation. Understanding the cause of the disease is important because the prognosis, the likelihood of occurring to the family again, and the treatment are all dependent on the molecular mechanism. Angelman syndrome has recognizable features that can be detected by clinical geneticists. However, distinguishing genetic subtypes within this disorder can only be done through extensive testing. In this study, we used deep Gestalt, a facial analysis technology based on artificial intelligence, to distinguish subtle facial features between different molecular classifications of Angelman syndrome. We analyzed 261 images of individuals with Angelman and generated average composite images based on the subtype they belong to. We then used deep Gestalt to perform comparisons between images of different molecular subtypes of the disorder. The results are reported as areas under the curve, or AUC. An AUC closer to 1 represents the system's ability to perfectly discriminate two subtypes, while AUC values that are closer to 0.5 mean that the system cannot tell the difference between the two types of Angelman syndrome. In our results, we found that the system was able to discriminate between a deletion and disorders of methylation, while it was unable to differentiate a mutation in the gene from other subtypes. This suggests that there are subtle facial differences between different subtypes of Angelman syndrome. More importantly, our results suggest that this phenotyping technology may represent a useful aid in confirming a molecular diagnosis without the need to come to a children's hospital for testing.